Hello there. Welcome back. Now that you have all those t-tests in your toolkit, it's time to explore ANOVA. So let's dive in. Let's go. We're going to talk about ANOVA, family-wise alpha, also sometimes called experiment-wise alpha, hypotheses formation for an ANOVA. We're going to visualize some ANOVAs. We're going to talk about the sources of variation, and we're going to talk about the ratio between and within group variance. Let's carry on. Thus far, we have been comparing one group to another group, whether this is a known group, a known population mean like a national average, another sample, a totally different group, or some sort of pre- and post-test scores. But what do we do if we want to compare more than two groups? What do you think we should do? ANOVA! ANOVA stands for Analysis of the Variance. Where did ANOVA come from? Well, I think that means it's time for a historical moment. This lesson's historical moment is brought to you by Ronald Fisher. He was a British statistician and geneticist. He combined Mendelian genetics, think about those P's, and natural selection using math. Awesome. He also did many other things like maximum likelihood estimation, which is beyond the scope of this class, but it is awesome. Population genetics, and what we're dealing with today, ANOVA. But why is there always a but? He really liked Francis Galton, and he was really into this idea of heredity and planned reproduction. He was a really loud and proud eugenicist. Remember eugenics? The whole letting good stock breed and possibly forcefully sterilizing those that are bad stock. And he left no doubt when he said that the Nazis sincerely wished to benefit the German racial stock, especially by the elimination of manifest defectives, and he would have given his full support to such a movement. Thank you for your contributions, but no. Moving on. Enough of him. So you might be wondering, why on earth do we do this special ANOVA thing when we could just do a bunch of t-tests? I mean, it's the same thing, right? Well, first off, if we had 4 groups, we would have to do 1, 2, 3, 4, 5, 6 t-tests. It's a lot of t-tests to be running, but I mean, it's possible, right? But what's really important, and the reason that ANOVA is so powerful, is that when we do this, if we were to run a whole bunch of t-tests, our 0.05 level of significance that we set, the convention, it actually gets a lot bigger than 0.05. The likelihood of you making that type 1 error, that 0.05, it's related to that 0.05 chance, increases the more and more tests that you run. This is called family-wise or experiment-wise alpha, and this is what we are trying to control when we are doing ANOVAs instead of a whole bunch of t-tests. So experiment-wise or family-wise alpha is when you set your alpha level to 0.05, but really it's getting much higher than that because you are running a whole bunch of these 0.05 t-tests. So it actually compounds and it's no longer 0.05. So ANOVA helps us handle that. As always, we need to discuss a null and alternative hypotheses for our test. What do you think the null and alternative hypotheses might be for ANOVA? As usual, our null says something like everybody's the same, everything is equal. So in this case, we would say there's no difference between the groups, all the means are equal. We can say mu1 is equal to mu2, equal to mu3, equal to mu4. The alternative, now this is a very important little semantic distinction. It states that at least one of the group means is different from the others. So we don't know which one, it's just saying that at least one of them. And the way that you write that out is just that mu1 is not equal to mu2, not equal to mu3, not equal to mu4. But again, the alternative is actually only stating that at least one of them differs. It might be, they might all differ from each other, but if you get a significant test, it's saying that at least one mean differs significantly. As always, let's start with an example. I want to know whether there is any difference in using different materials to learn statistical literacy as assessed by an exam. I have 3 different groups. One group is going to use a book only to study. The next group is going to study only with the lecture notes, like the PowerPoints. And the last group is going to study with both the book and the PowerPoints. So what am I going to compare to test if at least one group differs from the other? So what am I going to compare to assess differences? Well, it's called an analysis of the variance, so we're going to be looking at variance. Eventually we're going to compare the means, which is what we're used to doing. But first, we are really testing the variance between and within the groups. ANOVA Visualized. Let's go back to our study example. We have 3 groups and each group has 10 people in it. In group 1, they use the book only, group 2, lecture notes only, group 3, lecture and book. Then we have 7.6, 17.6, and 19.3 respectively. Just by looking at the results, do you think that they are going to be significant? Which group means do you think will be statistically significantly different from each other? Do you think group 1 will differ from group 2 or from group 3? Do you think group 2 and 3 will differ? Keep this in mind. Let's start with the variance within one group. So with all of our examples, we always are calculating some sort of variance and a standard deviation. Nothing new there. So for group 1, everybody in that group is going to have their own variance within the group. Nothing different there. So one person might score as high as 15, but the average score is only 7.6, or somebody might have gotten a 0. So there's going to be a lot of variability just within the one group and all their individual differences from each other. Now in an ANOVA, there are usually 3 or more groups, and each one of those has their own within group variance. So the ones who studied with the book, they're going to vary from each other in their own way. The ones who study with just the lecture notes will vary from each other, and the last group will also vary from each other, just from the people within their one group. Let's look at this variability in a different way, using some box plots. Which of the 2 scenarios below has more within group variability, meaning the people within each group differ a lot from each other? Would you think scenario 1 or scenario number 2? In this case, it would be scenario number 1. Remember, box plots show this is 50% of the data, and from here to here is the full 100% of the data. So there is a lot more variability in scenario number 1 than in scenario number 2. Look how nice and tight everything is. Now let's think about this. If you were trying to figure out if there was any differences due to your grouping variable, that could be the independent variable, the treatment variable, the intervention, in this case it's how you studied. If you want to figure out if there are differences in that, in which scenario would that be easier? In scenario number 1, when people even just within the group differ a lot from each other, or scenario number 2, where people in each group are fairly similar to one another? Said another way, is it easier to see between group differences when the variability within each group is large or small? What do you think? In scenario number 2, where the within group differences are small, people within each group are fairly similar to each other, it would be much easier to see those group differences in this scenario down here. So it would be ideal if everybody within a group was very similar to each other, but then people between the groups were very different from each other. Within group variance is the variability that is not due to the independent variable, that grouping variable, whether they are studying with the book or studying with lecture notes or both. This is just regular differences between people, just people being different from each other, as we all are. So if within group variance is just that pre-existing differences among people, what other type of variance are we interested in looking at? We can also look at the variance between groups. We can compare how different on average each group is from the other. Between group variance is the good stuff, at least as a researcher. This is the stuff that we want to investigate because this is the stuff that's due to your independent variable, that grouping variable. So how much did the groups vary from each other based on which group they were in, based on the way that they studied? The grouping variable is our independent variable of interest. Let's think about it again. If you're trying to figure out if there are any differences due to grouping, that's the independent variable, that treatment effect, or the intervention, or in this case, the different ways that people studied, in which scenario would it be easier to see those differences? In scenario number 1, where within group variance is very high, meaning that the people within each group are very different from each other. So in this group 1, some of the lowest low are down here, but some of the highest in that low group are in like the mean of the highest group, so there's a lot of overlap. Or would it be easier in scenario number 2, where the within group variance is very small? Each group, the people within that group are very similar to each other, but then the groups differ from each other. Which would it be easier to tell which group you're in? Scenario number 1 or scenario number 2? Now I like to imagine this, these little balls right here, imagine that's a person. And imagine I reach in, pluck one out, and it has a score of 10. Now in this scenario, would I know where that came from? looks like 10 is an option for the first group, the second group, and the third group. So I wouldn't have any sense of where this person came from. But this example, if this were a 10 and this is the mean 7, this is the mean 12, we would have a pretty good idea that that 10 came from either group 2, maybe group 3, but certainly not group 1. So this is a much better situation. It's much more distinct. Now that you know about within and between group variance, which of these 4 situations do you think is the optimal variance situation to find some group differences? And why? Which one do you think it is? Take a moment. Did you guess low within and high between? That is our scenario number 2 here, where people within their own groups are fairly similar to each other, but very different between the groups. And lastly, we also have something called total variance, and it is, as you would expect, between variance plus within variance, and that is the overall variance of your entire sample. ANOVA and ratios. Let's round up all these variances. What are our 3 types of variance again? Which one is related to error? And in this case, error does not mean that somebody made a mistake. It's just all the variance that is not accounted for by our independent grouping variable. So which one do you think is error and which one do you think is related to the independent variable? Here are our 3 types of variance. We have within, which is the error due to just individual differences. We have the between, which is group variance that is due to your independent variable. And then we have the total variance, which is the combination of the within and the between. So which of these variances do we want to compare to see if that grouping variable, that independent variable, the way that you studied, to see if that had any effect? Which of these do we care about? How do we want to compare them? So let's look real quick at what a ratio is again. It's the relation between one amount showing the number of times one value contains or is contained within the other one. Still a little ambiguous. So let's do a more tangible example here. You probably have some monthly income, and you probably have some monthly bills. Now, depending on the value of each of these, you could either be left with a surplus, a debt, or have exactly 0. You pay off all your bills and you have $0 left. Now, if the ratio between these two was equal to 1, what would that mean? If the ratio between these two was greater than 1, let's say a positive 2, what would that mean? And if the ratio was less than 1, let's say 0.5, what would that mean? Take a moment to think about this with your own lives and your own bills and your own incomes. Let's examine each of these scenarios. In the first situation where let's say your monthly income is exactly equal to your monthly bills, so you have $1,000 in income, $1,000 in bills, this will equal 1. And you will be left with a 0. You don't have to owe anything and you don't have any extra. Now if your monthly bills are less than your income, this will result in a ratio greater than 1. So if you have a ratio, let's say, of 2 here, that means that you make twice as much, $2,000 for your $1,000 of bills. Yay! You can save some money, which is good. Then we have scenario number 3, where if this is less than 1, that means that your bills are more than your income, so you have a debt. Hopefully not. That is a tangible income and bill example. Let's relate this back to our ANOVA. Now in an ANOVA, the variances that we're comparing are the between group variance and the within group variance. So now look what's going on here. This is like our bills, and this is our income. We want a surplus. So if a ratio is equal to 1, what does that mean? If the between was greater than the within and the ratio is greater than 1, what do you think that means in terms of our statistics example here and trying to figure out if there are true differences between the groups? And lastly, what would a ratio of less than 1 mean? If we were a researcher, which situation would we hope to see if we were testing a new intervention and we really hoped it worked and we wanted to see those group differences? Would we want situation 1, 2, or 3? Think about it. If we were a researcher trying to find those differences, we would really hope that we would see that the between group variance is much more than the within group variance. So all the differences in your study are due to the groups, not just because people are different from each other and super individualistic, but because your groups are very different from each other. That would mean again that the within group variance here is less than the between group variance up here. We can also think of it as the explained variance over the unexplained variance. What is the ratio between the amount of variance you are explaining and not explaining? Now again, explained variance is due to the grouping variable. And then the unexplained, which we call that error variance, is just within differences, people just being different, and we're not accounting for that. That's why it's unexplained. We don't know why each person is so different from everybody, but we do know that some of the groups are different from each other. So explained variance due to between group variance, unexplained variance due to within group or error variance. Now that we've looked at these ratios, we've formulated our hypothesis, it is time to actually look at some ANOVA output and interpret it. I will see you